Students, in this lecture we will discuss the fastest method to compute Fourier transform, the direct Fourier transform. So there are two methods to compute. The first one is Dit-FFT, and the second method is DIF-FFT. See, these two methods are efficient to calculate the DFT method in a quick manner. The computation is very fast. Okay, so we will see first the DIT-FFT method. So in all the lectures, people will discuss only the direct method. I mean, they will not follow the shortcut method to compute DIT-FFT and DIF-FFT. So in this lecture, I will teach you what is the shortcut method to compute the DIT-FFT. Okay, and also you can verify your answers. Even though you calculate the direct method, you can verify your answers by using this shortcut method. So we will see first DIT-FFT, and this is the butterfly diagram for DIT-FFT method. So, and in DIT-FFT, the inputs are in bit reversed order. Okay, the output are in natural order. And then we are going to see the 8-point DFT. Which means the 8 input discrete sequences will be given, and for this 8-point DFT we need to calculate DIT-FFT method. Okay, so the 8-point DFT are the sequence x of n equal to 1, 2, 3, 4, 5, 6 and then 7. Okay, so I'm going to directly apply the inputs. So this is decimation in time. So DIT stands decimation in time. So the inputs are in bit reversed order. So therefore this is 0, 4, 2, 6, 1, 5, 3 and then 7. Okay, so these are the bit reversed order. So bit reversed order means if we start with 0, 0, 0 up to 1, 1, 1, let's say this is 0, 0. If I reverse the order of the binary bit sequence, this will become 1, 1, 0, 1, 0, 0, which means this is 4. Okay, so this method I followed here at the input side. So the other things on the butterfly diagram are this is -1, this is, so I'm not going to explain these details. What I'm going to explain is the shortcut method to verify your answers. This is -1 and this is -1, -1. Double 8 power 0 to 8 power 2, 0, 1, 2 and then 3. See, what are the things you need to remember to work out the FFT problem, or whether the input sequence or in bit reversed order or the output sequence are in bit reversed order, and the values of the twiddle factors W8 power 0, W8 power 1, W8 power 2, W8 power 3. Okay, these are the things you need to remember. So the shortcut method is actually this is x of 0, 1, 2, 3, 4, 5, 6, 7. Since the inputs are 0, 1, 2, 3, 4, 5, 6 and 7, if you add all the numbers you will get 28. Okay, so that is the x of 0, that is the first value in the output. Then we can calculate x of n by 2. What is x of n by 2? This is 8 point DFT, n equal to 8. So x of n by 2 equal x of 4. Okay, where is x of 4? So this is x of 4. How do you calculate x of 4 directly without going this much computations inside? What you can do is you have to apply the plus and minus signs to the inputs, which means this is plus 0 and then minus 1 plus 2, this is 0, plus 2 minus 3 plus 4 minus 5 plus 6 minus 7. So you have to add the alternate signs to the input sequence, and once you perform this, what you will get? You will get minus 4. Okay, so that is the answer for x of n by 2, that is minus 4. Now you have calculated two values like x of 0, so this is x of 0 and this is x of 1, and then remaining you have to calculate 6 values, but I'll say you have to calculate 3 values and then their complex conjugate or the other 3 values. What you're going to do, you're going to calculate x of 1, x of 2, x of 3, and these remaining 3 values are the complex conjugate values. This complex conjugate value is defined by using the complex conjugate property of the DFT. Simple. Okay, you can refer what is the complex conjugate property. So I think x of n minus k is equal to, sorry, x of n minus k is equal to x star of k, I think, if I'm right. Okay, let's say if k equal to 1, then x star of 1 equal to what is x of 7. So the first value, so this is x of 1. If I calculate x of 1, if I take complex conjugate of x of 1, then there, that is the value for x of 7. Okay, simple. So now I am going to calculate the values for x of 1 through x of 3. Okay, the remaining values are complex conjugate. Now what is x of 1? That too even easy. I'll tell you the shortcut. Now what is answer over here? If I add 0, the 0 is coming over here, and this 4, what is value for w8 per 0? W8 per 0 is 1. So obviously if I add here, this is 4, this is minus 4, and if I add 2 plus 6, I will get 8 here. And what is answer for here? This is 2 minus 8 equal to minus 6. Sorry, 2 minus 6, this is minus 4. 2 minus 6, this is minus 4. Similarly, what's here? If I add 1 plus 5, I'll get 6. 1 minus 5, I'll get minus 4. Similarly, if I add 7 plus 3, I'll get 10. This is 3, and because of this minus 1, I'll get 3 minus 7 equal to minus 4. Okay. Now I have calculated the first stage of values, and these are all the first stage values. Okay. And now what is this value? This is 4. 4 is coming here, and W8 power 0 is 8. So 4 plus 8 is 12 simply. And then calculating this value is very easy. Instead of calculating this value is very easy. Why? Because W8 power 0 is here. So for W8 power 0 the value is 1. So what is this value? This is minus 8. 4 minus 8. Okay, 4 is coming all the way from here, and then this is minus 8. 4 minus 8 is minus 4. Okay, and then what is this value? This value is minus 4. This is once you, if you calculate through the calculator, it is minus 4 plus 4j. Okay, you can work it out in the complex mode. Similarly here you will get minus 4 minus 4j. Similarly, if you add 6 plus 10, 16. This is minus 4 plus 4j. This is minus 4 again. This is very easy since because we have W8 power 0 here. W8 power 0 is 1. 6 minus 10 is minus 4. And then this is W8 power square. W8 square is minus j. That you can do it very simply. Okay, minus j. Minus j, if you multiply this minus 4, this minus j and minus 1. And if you add, you will get minus 4 minus 4j. Okay, so wherever you have W8 power 0 and W8 power square, your calculation is easy since W8 power 0 is 1, W8 square is minus j. Now what you're going to do, you have to add this 12 plus this 16. Okay, what is now the answer? You will get 28. Okay, as we calculated initially, we obtained the addition of all the input samples value, we get 28. Okay, and then this is W8 power 1. W8 power 1 is 0.707 minus j 0.077. If you cross multiply, and you will get the answer is minus 4 plus j 9.656. Now the answer for x of 7 is the complex conjugate of x of 1. What is that? Minus 4 minus j 9.656. And then if you calculate the w here, x of 2 value, that is W8 square. We have W8 square. The calculation is very easy. That is minus 4 plus 4j. Since we have calculated the x of 2, what is x of n minus k? That is x of 6. The complex conjugate. What is complex conjugate? Minus 4 minus 4j. Simple. And then this value x of 3 is minus 4 plus j 1.656. Since x of 3, then x of n minus k. What is x of n minus k? N is 8. So k value is 3. We will get x of 5. So this complex conjugate is minus 4 minus j 1.656. Okay. So the calculation of FFT is very easy. Only thing you have to do is you have to multiply this W8 power 1 and W8 power 3 is difficult. Okay. Other than that, W8 power 0 is 1, W8 square is minus j, and the job is very easy. Only you have to calculate the first 5 points, x of 0 to x of 4. Okay, x of 0 is addition of all samples of x of n, and x of n by 2 is you have to assign alternate symbols, alternate signs to the input samples, and then you have to add all those things. And then if you compute the first 3 points and its complex conjugate or the remaining 3 points. Okay, so in this way you can calculate very easily the butterfly